You know, our world is built on chemistry. But have you ever stopped to think about the invisible rules, the huge unseen system that governs all that stuff and is designed to keep us safe? Well, that's what we're diving into today. Let's just jump right in. Look around you right now. Think about the t-shirt you're wearing or the phone that's probably in your hand or pocket. What's really in them? They seem so simple, but they're actually incredibly complex little packages of all sorts of materials. So to figure that out, we got to start with the basics, the fundamental building blocks. And you know what? It's probably a lot simpler than you think. Turns out, pretty much every single product can be broken down into just one of three categories. First, you've got a pure substance, like citric acid. Simple enough. Then, you can combine a few substances and you get a mixture. Think about a can of paint. And finally, you can shape those materials into an article, where the design itself is the main thing, like your t-shirt. Everything, and I mean everything from a simple chemical to a complex smartphone, fits into one of these buckets. And here's the thing, right? Chemicals are incredible. They make our modern lives possible. But some of them can be harmful. That's the balance we have to strike. We need a system that lets us get all the benefits of chemistry without putting our health or the planet at risk. And that brings us to the system itself. The best way to think about it is like the rules of the road for chemical safety. It's all about preventing accidents before they even have a chance to happen. You know, the entire philosophy behind all of this isn't even new. It's built on this super simple idea from way back in the 17th century. Prevention is better than cure. It's all about being proactive instead of just reactive. And this really shows you the giant leap in thinking. For a long, long time, the approach was basically reactive. Wait for a chemical spill, then figure out how to clean it up. The modern approach, the preventive one, is about stopping the problem at the source, right at the beginning of the supply chain. Honestly, it's just smarter, safer, and at the end of the day, way less expensive. Okay, so whose job is it to make sure these rules are actually being followed? Let's meet the two key players on this safety team. It's basically a partnership. On one side, you have the industry, the companies making and importing the chemicals. Their main job is to know their products inside and out, figure out the risks, and label everything correctly. Then, on the other side, you have the government, and they act as the referee. They set the laws, they enforce the rules, and if a chemical is just too risky, they can step in and ban or restrict it. It's a real system of checks and balances. So how does this whole safety team actually do its job? Well, it all boils down to a really clear three-step process. It really comes down to these three things. Think of it like a detective's investigation. Step 1, gather information. What exactly is this stuff and how is it being used? Step 2, assess the risk. Okay, what harm could it actually do? And step 3, the most important one, take action to control that risk. It's a simple, logical path to keeping everyone safe. Now, that second step, assessing the risk, it all comes down to this simple but incredibly powerful formula. Risk equals hazard times exposure. You see, risk isn't just about how dangerous a substance is, that's the hazard. It's about how dangerous it is multiplied by how much we're actually exposed to it. You could have a super hazardous chemical, but if it's locked away where no one can touch it, the risk is low. On the flip side, a less hazardous chemical that we use every single day could have a really high risk. Getting this equation is absolutely key to understanding the whole system.
So, when it's time to take action, what can the authorities actually do? Well, they have a whole toolkit full of different ways to protect us.
And these are some of the heavy hitters in that regulatory toolbox. For the really dangerous stuff, they can issue an outright ban. Or they can apply restrictions, which means a chemical can only be used for very specific things. Sometimes companies need an authorization before they're even allowed to use it. And, so importantly, they enforce clear communication through things like classification and labeling and those super detailed safety data sheets. And one of the most important communication tools is something called GHS, the Globally Harmonized System. Just think of it as a universal visual language for chemical safety. The goal is so simple but so powerful. Make sure a hazard warning looks exactly the same whether you're in New York, Nairobi, or New Delhi. Oh, you have absolutely seen these. I bet if you look under your kitchen sink right now, you'll find them on cleaning supplies. That skull and crossbones means it's seriously toxic. The flame, of course, means it's flammable. Each one of these little pictures gives you vital safety information instantly so you can understand the risk in, well, a glance. So why does all of this matter so much, especially right now? Okay, let's zoom out for a second and look at the big picture for our future. Get this. In 2017, global chemical production hit 2.3 billion tons. That is a staggering number. But it's projected to double by 2030. Double. With that kind of explosive growth coming, having these strong, proactive rules of the road isn't just a nice idea. It's absolutely critical. This whole system is the foundation for creating a non-toxic environment, and really, it's a cornerstone for sustainable development for all of us.
So this system gives us the framework for safety. It sets the ground rules. The real question, the one that's left for us, is now that we know the rules of the game, how do we, as innovators, as consumers, as citizens, use this knowledge to build a truly safer, non-toxic future? That's the real challenge ahead.